Hello everybody, welcome to the second half of chapter 2.3, and what we're going to talk about is long division. Specifically, we're going to use long division to find factors of polynomials and zeros of polynomials, kind of like how we use synthetic division to find factors and zeros. So let's do a quick recap of what long division is. And I'm just going to go through some quick examples with you guys. This shouldn't be that long of a video. But for example, if you're asked to divide, say, x cubed minus 1 divided by x minus 1, or maybe it looks like this. Right, these are both saying the same thing. Then what we can do is we can set up long division. We can put our x minus 1 on the outside, and we can have that little bar going, and then we can put in our thing we're dividing, which is x cubed minus 1. If you don't remember, you need to do something important here, though. When you are dividing a polynomial, the polynomial that you're dividing must have a coefficient for every variable. Even though there isn't technically an x squared in there, that's just because its coefficient is 0. So we're going to write in all of our 0 coefficients. So that is our polynomial that we're dividing. And where we begin is we ask ourselves, we look at this x and we look at this x cubed. And we ask ourselves, x times what gets me x cubed? And the answer is x times x squared. So when I write that, I don't write my x squared over here. I write my x squared above the x squared term. So this is where I begin writing. Okay. And now I multiply back. I know x squared times x gets me that x cubed, so I'm going to line those up. And then I do x squared times negative 1, which will get me negative x squared. Here's the important thing to remember as well. You need to change your sign, because the name of the game right here is to get those two to cancel out, and right now they're both positive, so they won't cancel. So I need to change the sign here. I need to change the sign here. Now those two cancel each other out, and I'm left with 0 plus 1 would get me 1, x squared, and then I have to bring this guy down here as well, plus 0x. And as we're going through this, I hope that the process of long division is just kind of coming back a little bit more naturally, right? Even though we're using variables and binomial and a polynomial, the same rules still apply of basic division, where you have to take the next thing and bring it down. So now we're going to repeat the step that we did here, except we're dealing with x squared now. So we say x times what gets me x squared? Well, the answer is x. And so I put that x, that positive x, above my x term, and now I multiply back. I say x times x gets me x squared, and x times negative 1 gets me negative x. Now again, our goal here is to get these to cancel, so we have to change the signs. Make this negative, make this positive. These two can now be canceled out, and I get 0 plus 1 is 1. And then this guy joins the party. We get negative 1 down there. And now, same process. X times what gets me x? Well, the answer is 1. So I write my constant above my constant, and I multiply back. I do 1 times x will get me x, and I say 1 times negative 1 will get me negative 1. And now, again, change the sign of both. These would cancel out, and so would these. So I would get a remainder of 0. Oh, that's lovely. That worked out so well. So here's what our result means. We can say, in short, that x cubed minus 1 divided by x minus 1 equals this, x squared plus x plus 1. However, we still need to pay attention to the original domain, so we need to specify that x cannot equal 1. And what this means, what's more interesting about this, and my goal for you to take away from today's video, is that we understand a factor now. We understand that factors of x cubed minus 1 are x minus 1. Since x minus 1 divided into this without a remainder, that's most definitely a factor. Another factor is going to be what was left, what our result was. So it's going to be outside x squared plus x plus 1. And what we can conclude from this are some zeros. We can say that this will become a 0. We'll say when x equals 1, that's a 0. And this, I'll save you some time. We can see that it's not factorable because there's no two numbers that multiply to 1 and add to 1. So even if you use the quadratic formula, or if you looked at a graph of this, this is what the parabola is doing. It's all the way up here. So we can see that this is not factorable, and it also has no roots, so we won't get any zeros from this, or we won't get any real zeros from this. So this is our only zero of the function x cubed minus 1. So we can just kind of box that. That's the only zero. How cool. And we found that using long division. All right, let's do one more example. I'll use a different sheet of paper, actually. So let's do that. Alrighty, so, and again, this is just to kind of refresh your long division abilities, because sometimes the long division doesn't always work out with what they ask you to divide in order to find the zeros like we just did. But that's okay. It's still good for us to understand long division, so we're going to keep practicing it. Alright, so we're given this really long polynomial, 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2, divided by x squared plus 2x minus 3. And what we're going to do is we're going to set up long division once again. We're going to have x squared plus 2x minus 3. This one's a little nicer to us. We can see that every variable has a coefficient, right? We have every little degree filled in, 4, 3, 2, 1. So we don't need to put in any zeros for our coefficients. We just get to rewrite our polynomial. Plus 3x minus 2. Okay, great. Now we begin exactly the same way we did before. It doesn't matter that this is a polynomial now instead of a binomial. We still just look at the leading coefficient, and the leading coefficient. That's always our first step. And we answer that question, x squared times what gets me 2x to the 4th? And the answer is 2x squared. And now that I know that, I take that 2x squared and I multiply back. So I say 2x squared times x squared is going to give me 2x to the 4th. 2x squared times 2x is going to get me 4x cubed. And then 2x squared times negative 3 is going to get me negative 6x squared. Now remember, you must change your signs in order for anything interesting to happen, in order for, this is a negative now, and this is a positive, okay, in order for your terms to cancel out. So those cancel now. Oh, take a look, these cancel, that's lovely. Now we have negative 5 plus 6, which will get us 1x squared. And remember to give this guy a buddy, right? We have to bring down a term. All right, now we do the same process again. We say x squared times what gets me x squared, and the answer is 1. And again, I'm going to write that 1 above my constant. It's important that when you write out your answers to these questions, you put them above their corresponding term in the, what did we call that? Just going to call it the division bar. I'll get back to you on that because I'm fairly certain that's the wrong vocabulary term. But what I'm trying to say is that these variables and the constants line up. And that's what you should do in your own work. Okay. Now that I know the number that goes up here, I'm going to use it to multiply back. And I'm going to do... we forgot something. Hang on. And I shouldn't say we, I'm the one doing this, sorry. Okay, so it's important that the amount of terms you have here to be divided with match what you are dividing by. So we had 3 terms. We need to always have 3 terms here as well. We need to match the numbers. So we don't just bring down the 3x, we need to bring down the -2 as well. Okay. Now that we've done that, we're going to use this 1 and we're going to multiply back. So we're going to say 1 times x squared is going to get me x squared. 1 times 2x gets me positive 2x. And 1 times -3 gets me -3. And now in order for anything to cancel out, in order for interesting stuff to happen, we're going to change the sign, make this a -2x, and change the sign, make it a positive 3. Okay. Now these will cancel. I will get 3x minus 2x, 1x, or just x, and then -2 plus 3, I will get 1. Alright, so let's write out our answer. Let's write out what this all really means. 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2, that is a mouthful, over x cubed plus 2x minus 3 is equal to what's up here. So it's equal to 2x squared plus 1, but we also have a remainder of x plus 1. And here's how we take care of that remainder. We add it at the end. We say x plus 1 over what we chose to divide by, which is x squared plus 2x minus 3. And that is all we write. We don't get to have a discussion with this problem about factors or zeros because we had a remainder. If our remainder is 0, then we find a factor. But if the remainder is not 0, if it's anything other than 0, then we don't get to say that, and we instead just state our answer as we did here. Okay, thanks for watching. We'll see you in class tomorrow.